Hello everyone, welcome back to your own mathematics channel asm.geniusjunction. I am Abhishek sir, your mathematics mentor. In today's video, we are going to cover 9709 Mathematics Paper 6 Unit 2 Poisson Distribution. This is your video number 1 and the topics which we are going to cover in this video are Introduction to Poisson Distribution, necessary parameters to model a question by Poisson distribution, when modeling data with Poisson distribution, the things which we need to take care of, and Poisson distribution expression and notations. Let's start without wasting time. Introduction to Poisson distribution. A Poisson distribution can be used to model a discrete probability distribution in which the events occur singly, at random, and independently in a given interval of space of time, and the mean and the variance of the Poisson distribution are equal. Hence, a Poisson distribution has only one parameter. This is the definition. So let's understand what is meant by this definition mathematically. Okay, so let's start. What is Poisson distribution, and let's understand its mathematical aspects. Poisson distribution, first of all, the very important thing which we need to understand, this is Poisson distribution which we are studying today. Okay, so first thing which we need to understand is random discrete variable. What is meant by random discrete variable? When we say that x is a random discrete variable, it means that x can attain only certain values in the given interval. Values in a given interval. What I mean to say by speaking this, so let's take an example to understand this. Suppose if I say that example x represents number of students sitting in class. Now in this particular example, the answers can be x is equals to 4, 7, 10, 12, 20, 30, but it cannot be equal to 27.2. So x can take only certain values in this case. So this particular example represents random discrete variable aspect. Now we will understand what is meant by random continuous variable. So when we talk about random continuous variable, it means that x can attain any value in a given interval of time. Okay, so let's understand this thing also with the help of an example. Suppose x represents the time taken by Usain Bolt to complete a 100-meter race. In this particular example, you understand that Usain Bolt can take any time interval between let's say 7 to 12 seconds. So he can take 8.345 or 9.441, anything between the given interval of time between 7 seconds to 12 seconds. So this particular example represents random continuous variable. Okay, so now I hope that you are able to understand what is meant by random continuous variable and random discrete variables. Let's proceed further. Now we are talking about Poisson distribution. Yes, so now we will talk about Poisson's distribution. What is meant by Poisson's distribution? This is our heading to understand now. If x is following Poisson distribution, then the following conditions will be met out. Following conditions must be fulfilled. The number one condition is all the events should occur singly. Condition number two, all the events should occur randomly. That is, the events occurring should not be connected with each other. Third, the probability of occurring any two events consecutively should be independent. Fourth is each event should have constant probability of occurrence. Should have constant probability of occurrence. And the next one, which is the last, is event should occur in a given space of time. So these five are the necessary conditions for an event to be a part of a Poisson distribution. So if all these five conditions are fulfilled, so we will say that the given event is actually following Poisson distribution. So let's understand that what happens if event X follows a Poisson distribution. X is representing as number of vehicles passing from a road in every 10 minutes. This particular event is representing a Poisson distribution. There can be some other examples as well. For say that let X represents number of patients entering into the clinic in every 30 minutes. So these two examples are the examples where how a Poisson distribution question looks like. In both the questions, X is representing something which is occurring singly, randomly, independently. Each event is having a constant probability of occurrence, and both the events are time-bound events. So we can see that X in both the cases is actually following Poisson distribution. So a question which is based on Poisson distribution will be following all the five parameters stated above. That is, it will be occurring singly, randomly, independently. Each event will have a constant probability of occurrence, and the events will be occurring in the given space of time. As you can see that it is occurring in 10-minute and 30-minute interval. So such type of questions are modeled with the help of Poisson distribution. So let's proceed further and see that how we solve a question which is based on Poisson distribution. If event X is following Poisson distribution, if an event is following Poisson distribution, then X is following Poisson distribution. This is the way we write that. This is your lambda. It is read as lambda. This is lambda, and here it is actually representing mean, and actually mean is always equals to variance. So I will write that mean and variance both are equal. So in case of Poisson distribution, we always remember this thing. When we are talking about Poisson distribution, mean and variance are going to be equal to each other. So this is the notation in which the way we represent Poisson distribution. So if X is following Poisson distribution where lambda represents mean and variance, then probability of x is equals to r is calculated by the formula e raised to the power minus lambda times lambda raised to the power r over r factorial. This is the complete expression for calculating the probability of x is equals to r. Okay, so let's understand this thing, how to apply this particular formula on the questions. So let's take one question right over here. Suppose let x follows Poisson distribution with mean as 6. So when I'm writing 6, it actually represents mean and variance both, right? So this is actually the condition for Poisson distribution. If mean and variance are equal, then only the data can be modeled by Poisson distribution, right? So mean and variance both are equal. And now what they are asking, first let's say what will be the probability of x is equals to 3. How we calculate this? So formula is stated right above, so I use it, and this is e raised to the power minus lambda times lambda raised to the power r, that is 3, over 3 factorial. We can use thing by using calculator, so let's see how we use this. So we can see this is e raised to the power minus 6 times 6 raised to the power 3. So let's use bracket 6 with exponent as 3 and whole expression divided by 3 factorial. So this is representing 36 over 6. In decimal representation it is 0.0892. Okay, so let's take few more questions. So how we are going to solve a question like probability of x less than 3. In this case, it actually represents probability of x is equals to 0, 1, 2. So probability of x is equals to 0 plus probability of x is equals to 1 plus probability of x is equals to 2. How we are going to apply this thing, let's understand. So I will write e raised to the power minus lambda times lambda raised to the power 0 over 0 factorial. This is probability of x is equals to 0. Then e raised to the power minus lambda times lambda raised to the power 1 over 1 factorial plus e raised to the power minus lambda times lambda raised to the power r over r factorial. So I will take out e raised to the power minus 6 common from all of them, and I will get 6 raised to the power 0 is 1 and 0 factorial is also 1. So I will write it as 1 plus e raised to the power minus 6 is already taken out common. So I will be left with 6. 1 factorial is 1 only. And then it is 6 square, that is 36. 36 over 2 will give you 18. So now we can easily solve this. Let's use calculator. So this is 18 plus 6, 24 plus 1, 25. So we will directly solve this. E raised to the power minus 6 times 1 plus 6 plus 18, that is 25. And now we are getting the final answer as 0.061 and 96. So this is actually going to become, when I will round it off this number, so I will get 0.620. Okay, so now we have understood that if we want to calculate the value of x is equals to 3, this is the way we use it. When we are calculating probability of x less than 3, means 0, 1, 2. Let's move on and understand the other ways in which the question can be asked. So first, the third one is probability of x less than equals to 3. In this case, we will calculate probability of x is equals to 0, 1, 2, 3. And now I will write it directly, so it can be written as e raised to the power minus lambda times lambda raised to the power 0, then lambda raised to the power 1 over 1 factorial plus lambda raised to the power 2 over 2 factorial plus lambda raised to the power 3 over 3 factorial. Bracket close. Let's solve this. E raised to the power minus 6. This is going to be 1 plus 6 plus 18, and now 6 factorial 6 raised to the power 3 is 216, and 3 factorial is 6. Now we can use calculator now to find out the answer. So e raised to the power minus 6 kept as it is. Let's use bracket. This is 1 plus 6 plus 18 plus 216. Let's write it as 6 raised to the power 3 directly so that we can have correct answers, and then denominator is going to be 3 factorial, that is 6. So we are getting final answer as 0.151 answer. Okay, so till now we have understood that suppose if we want to calculate probability of x is equals to 3, we used the Poisson formula like this. Less than 3 means 0, 1, 2. Less than equals to 3 means we are talking about 0, 1, 2 and 3 as well. Now let's move on and understand how we are going to deal a question which is saying that probability of x greater than 3. Yes, so when we need to calculate probability of x greater than 3, we actually write it as 1 minus probability of happening of x is equals to 0, 1, 2, 3. Okay, so this is going to be like this: 1 minus probability of 0, 1, 2, 3, that is e raised to the power minus 6, and then x is equals to 0 actually gives you 1. Probability of x is equals to 1 gives you 6. Probability of x is equals to 2 gives you 6 square over 2 factorial. X is equals to 3 gives you 6 raised to the power 3 over 3 factorial. So now we need to quickly solve this. So I will write 1 minus, let's use bracket now, calculator now. So we will write 1 minus e raised to the power minus 6 now, and then let's open up the brackets. In the brackets we are having 1 plus 6, that is 7, plus in the numerator I am having 6 raised to the power 2 over 2 factorial. 2 factorial is actually 2, so I have written it directly. Then 6 raised to the power 3 over 3 factorial. So this is 3 factorial now, and let's close the brackets, and this is what we are getting as the final answer: 0. Okay, so let's quickly write down the final answer. This is what we are getting: 0.8487. So I will write it as 0.849. Okay, in the 3 significant figures. So probability of x greater than 3 is calculated in this way. So let's move on to the next question, that is probability of x greater than equals to 3. Now I believe that you all are able to understand how to solve these types of questions. Now we will calculate 1 minus probability of x is equals to 0, 1, 2. Okay, because he is talking about probability of x greater than equals to 3. That means we will calculate only 0, 1, 2. So this is going to be very simple now. We will use the concept of fourth question. This is e raised to the power minus 6. 1 plus 6 plus 6 square, 36 over 2, that is 18. And now we will quickly find out the answer. Let's again use calculator for the same thing. I will remove the last calculation part only, because rest of the things are same, right? So you can see that it is 1 plus 6 plus 18 actually. So let's write down the answer for this, and the answer is 0.938. Okay, yes. So till now we have understood that this is the formula for Poisson distribution, And if we need to apply a Poisson distribution, our question where it is saying x follows Poisson with mean as 6, where mean and variance both are equal in case of Poisson distribution. So probability of x is equals to 3, less than 3, less than equals to 3, greater than 3, greater than equals to 3. Okay, so without wasting time, let's start by taking few questions to understand the concept of Poisson distribution. What it says, x follows Poisson distribution with mean 4, and they want you to calculate probability of x less than 3. How we are going to solve this? Very simple. Let's have a solution of it. So we will write probability of x less than 3 actually means that we need to solve probability of x equals to 0, 1, 2. We will not take 3. And now we will write e raised to the power minus lambda, that is minus 4, then bracket, then e raised to the power minus 4 taken out common. I will be having for 0 it is 1, for 1 it is 4, and for 2 it is going to be 4 square over 2 factorial, that is. So we will calculate the complete expression value. So here it is. First of all, I will write down e raised to the power minus 4 as the common value. Then I will open up the brackets. In the brackets, we are having 1 plus 4 plus 4 square over 2 factorial. Now bracket is already closed. So let's calculate the answer. This is 0.238. 3 significant figure answer. So this is a way we need to solve the question. Simple. Okay, so now question number 2 says that in a particular town it was found that the potholes occurs independently at random at a rate of 5 in every 1 kilometer of a stretch. What is the probability that in a given stretch of 1 kilometer there will be fewer than 3 potholes? And B part says explain why this model may not be applicable to other towns. So these types of questions can come up in the examination. Let's see how we solve them. So let's write the solution part of it. So first of all, we will say that x follows Poisson distribution with 5 potholes per kilometer. Or I can more precisely write it like this only. This is x follows Poisson with just 5 over there. Okay. So now question number 1 says, what is the probability that in a randomly chosen 1 kilometer stretch of road there will be fewer than 3 potholes? Means we need to calculate the probability of x less than 3. That is probability of x is equals to 0, 1 or 2. So we will write it as e raised to the power minus 5, then 5 raised to the power 0 over 0 factorial plus 5 raised to the power 1 over 1 factorial, then 5 raised to the power 2 over 2 factorial. Close the brackets to get the final answer for this, and we will calculate this by using calculator. This is e raised to the power minus 5, this is 1, this is 5 itself, this is 25 over 2. So let's calculate this with the help of calculator. So this is e raised to the power minus 5, and then in the brackets we are having 1 plus 5 plus 5 square over 2 factorial. We are getting 0.1246. So I will write it as 0.12 and 5 in the 3 significant figures. This is going to be the final answer for the given question, right? And now let's move on to B part of it, and let's see what they are asking us. He's saying explain why this model may not be applicable to other towns. So I will write for other towns the pattern of number of potholes may vary, right? It is possible that in other town there is a different quality or variety of road, so the number of potholes found in particular 1 kilometer stretch can vary. So we can say that there can be a variation in the data set. Yes, so now we are having one more question of the similar type on in which we need to apply the Poisson distribution. So let's see how we apply a concept of Poisson distribution in this question. A question says, let's write down the solution of it. A question says that a fire station receives on an average one emergency call per hour. Okay, so X follows Poisson distribution with one emergency call per hour. Okay, so this is the case. So this is something which is given to us, and now A part first saying what assumptions do you need to make to model this situation by Poisson distribution. So I will write that event is occurring first of all singly, randomly. Third one is each event has constant probability of occurrence. And the last one, that is the event is time bound. So all the four conditions are fulfilled by this particular case. So we can say that yes, the given event follows Poisson distribution with following assumptions which they have taken into consideration. See, are the assumptions reasonable in this situation? So let's answer the B part of it, what they are trying to convey to us. We will write the assumptions taken into consideration while solving these questions. The assumptions taken are not reasonable. Why they are not reasonable? You can just imagine that fire station is receiving the emergency call. So the emergency call can be made by one person again and again, right? So I can write down that example. Suppose several people can make call the same fire station on the repeated basis. So this can be a reason that the given situation is cannot be modeled by Poisson distribution, right? And now B part saying that assuming the assumptions are reasonable, that is the given situation is modeled by Poisson distribution, what is the probability of 4 calls being received between 11 p.m. and midnight? Midnight means 12 in the night, right? So 11 p.m. to midnight means 1 hour, and the number of calls to be received is 4. So in B part we need to solve for probability of x is equals to 4, and x is following Poisson distribution with mean as 1 call per minute. So when I will solve this, I will write e raised to the power minus lambda bracket lambda raised to the power 4 over 4 factorial. Let's quickly solve this, and we will be getting the final answer as 0.0153. So this is the final answer for this particular question. I hope you people are able to understand how we are solving the questions based on Poisson distribution by using the formula of Poisson. Okay, so let's move on to next type of question. Yes, so now we are discussing one more question based on the same concept of Poisson distribution, in which a question says that a manufacturer of chocolate bars states that the number of hazelnuts in the randomly chosen 100-gram hazelnut chocolate bar can be modeled as a random variable having a Poisson distribution with mean 7.2. Now question says find the probability that in a randomly chosen 100-gram hazelnut chocolate bar there are exactly 8 whole hazelnuts, at least 4 whole hazelnuts, and the B part says that describe how would you check the manufacturer's statement. This is again a very good level question which can come up in the examinations. So let's try to figure out how we need to write the solution for it. Okay, so let's start with the solution of this particular question. In this question, x is following Poisson distribution with mean as 7.2. As you can see that it is given in the question. In part A, he's saying find the probability that in a randomly chosen 100-gram hazelnut chocolate, there will be exactly 8 whole hazelnuts. So that means he wants you to calculate probability of x is equals to 8. That is e raised to the power minus 7.2, then bracket open, then 7.2 raised to the power 8 over 8 factorial. When we will solve this using calculator, we will get our final answer for the given question as 0.134. This is the answer, right? After using calci. Now moving further, let's solve the second part. This is your first part of A. We are now dealing with the second part of A. At least 4 hazelnut. At least 4 hazelnut means probability of x is taken as greater than or equals to 4. So in this question, we will solve 1 minus probability of x is equals to 0, 1, 2, 3, right? So now we will solve this. So how we are going to solve this? This is 1 minus e raised to the power minus 7.2, bracket open. For 0, it remains 1. For 1, it will be 7.2. For 2, it is going to be 7.2 square over 2 factorial. And for 3, it is going to be 7.2 raised to the power 3 over 3 factorial. Close the brackets. Again, we will use calculators over here for the calculations, and the final answers for the given question is going to be 0.928. Okay, so we have done sufficient number of questions based on the topic which we have discussed in this video. I request you all to practice all the questions very effectively so that you can have a sound grip on this particular topic, so that you can understand the concepts which are going to be discussed in the videos after this. Thank you for watching the video. Please do not forget to like, share and subscribe the channel so that you can get the timely updates whenever we post a video. Thank you.